We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
It's been 50 years since we've been to the moon, and we've got a great program called Artemis. We're going back. The Apollo program was a test for the American people that you can do what you set out to do. All it took was turning to it and making it happen.
We are go for a mission to the moon at this time.
Engines on 5, 4, 3, 2. All engines running. Launch commit. Liftoff. We have liftoff 49 minutes past the hour.
I think the characteristic that I remember most of the Saturn V was the noise. The noise was enormous and it was almost impossible to communicate.
We're go, train tight, we're go. Tranquility Base here, the Eagle has landed.
The landing to me was a great celebration. The nation was almost euphoric.
It's one small step for man, one giant leap for mankind.
There are so many things that we could eventually learn about our universe and the spacecraft that we use exploring.
We are a nation of explorers. During Apollo, we were on national TV literally every day because we were doing something visible that Americans could see and they could feel and say, look what we are doing. And I believe Artemis is going to come up and say, look what we are capable of and what we are doing now.
Artemis will stand on the shoulders of Apollo. They're going to have the eyes of the world on them when they start down this trail.
The science of a space flight is one that will continue to inspire. Going to the moon generates technology, more communications, more computer technology, more sophistication in manufacturing that help us in everyday life.
We have a generation that is ready, a generation with that technology, a generation with the education. Artemis represents the future in space. It is our next big step, and it is time to take it.
I think that deserves a round of applause. That was amazing. Good morning. I'm William T. Harris, President and CEO here at Space Center Houston. We're a space exploration learning destination dedicated to bringing people and space closer together. We also have the privilege of serving as the official visitor center for NASA Johnson Space Center, the home of astronaut training and mission control. We share the story of human space exploration, past, present, and future, with more than 1.25 million visitors annually from around the world. Our mission is to reveal how science and humanity power space exploration. Space exploration has a great impact to our life on Earth. We benefit from a wealth of innovation, scientific advancements, and it broadens our views of the world and beyond. Today, we are absolutely thrilled to celebrate the 50th anniversary of the Apollo 17 mission, the final human mission to the moon during the Apollo program. The Apollo set the course for Artemis, the next era of human space exploration. Just this past Sunday, NASA's Orion spacecraft successfully splashed down, fulfilling a milestone with Artemis I, as we prepare to return to the moon, however with a new purpose. Space Center Houston houses a wide variety of Apollo-era artifacts, including America, the Apollo 17 command module. During your visit, please be sure to touch a piece of the moon brought back to Earth by the Apollo 17 mission and our Lunar Vault exhibit. See the Apollo 17 command module and experience our new exhibit, Artemis. Today we'll discuss lessons learned from the Apollo era, from the legends who lived it and paved the way for the future of space exploration. And we'll hear from current NASA experts who are realizing our future, We will revisit the last steps that we took on the moon and look at the journey we've launched to return. Thank you all to Space Center Houston members for joining us, and your support helps make possible all we do here. We have many staff from Johnson Space Center joining us in this audience. Thank you for your service to human space exploration. I also want to recognize two distinguished explorers who are with us today. Apollo 13 astronaut Fred Hayes, and shuttle-era astronaut Tim Kopra, who served on expeditions 20 and 46 on the ISS. Tim, I think you're here. Yes. Oh, there we go. We're also honored to be joined by the families of our legends and explorers. Jan Evans, who is the wife of Apollo 17 pilot Ron Evans, and many members of the Evans family. Jan. Also with us is Tracy Cernan-Woolley and Barbara Cernan-Butler, daughters of Gene Cernan and members of their family. Tracy? Barbara? Okay. I also want to recognize we're joined by members of the Ruse family. Stuart Rusa was the pilot for Apollo 14. So Rusa family, welcome. So a little bit of housekeeping. After our presentation, we'll take questions from the audience. So please stay with us for the discussion. We have a QR code that will be on the screen, so you can use your camera to take a picture of that, and you'll be able to text your questions to our moderator. It's now my great pleasure to introduce the moderator for today's program, Vanessa Wyche, who is the Center Director of NASA Johnson Space Center. Please join me in welcoming Vanessa.
Thank you, William, and I also extend welcome and greetings to everyone, and especially to our special guests that are joining us today. 50 years ago this month, the final mission in the Apollo program launched into the night sky. The crew of Apollo 17 completed humanity's last voyage to the moon. Harrison Schmitt, the first scientist to investigate the moon, was a geologist who had been part of the backup crew for Apollo 15. On Apollo 17, he served as pilot of the lunar module Challenger, and Eugene Cernan was commander, and Ronald Evans piloted the command module America. And as William said, you guys can actually see that particular spacecraft here at Space Center Houston. But at the end of their third and final EVA, Commander Gene Cernan spoke the now famous quote, "We leave as we came, and God willing, we shall return, with peace and hope for all mankind." And we're so very excited that through Artemis, we are now going to be returning, and returning in a sustainable way. So very, very proud of the work. As William said, you know, we were able to successfully launch Artemis, the rocket, with Orion on top. Orion had a very successful mission, and then we had splashdown on Sunday. It's just an incredible, incredible time. And that was an uncrewed mission, which now sets us up for our crewed mission on the next Artemis launch, Artemis II. But Apollo 17's mission was successful, collecting the largest batch of lunar samples, one of which we actually opened this year for study and investigation. But they set records for the longest time in lunar orbit and on the lunar surface. In the intermediary 50-year period from Apollo 17 to today, NASA's human spaceflight program has been working in low Earth orbit and preparing to pick up where the Apollo program left off. The 135 launches of the Space Shuttle program, the construction of the International Space Station, which we've now had our astronauts living off this planet for over 22 continuous years. I think that deserves a round of applause. But we've learned many lessons living and working in microgravity environment, which is now laying the groundwork for us to pursue Artemis, the Moon to Mars program. NASA's Artemis program is charting the course for an exciting new era in human lunar exploration. And this time when we go, we're going to be going in a different way. We're going to be going with our international partners, we're going to be going with commercial industry, and when we go, we will have the first woman and the first people of color that will go to the moon, and we will establish a long-term science and exploration capabilities to inspire the next generation of explorers, the Artemis generation, just as Apollo did. Today, we have the honor of hearing from Apollo 17 legends and Artemis leaders to discuss the past, present, and future of human space exploration. I'm going to introduce our panel, and they have very distinguished careers. If I were to give their entire bios, we'd be here the entire time. So we're just going to have some very abbreviated introductions of them. So first, our first panelist is Gerry Griffin, and he's our Apollo 17 lead flight director. Gene Kranz, Apollo 17 launch flight director, Moon and Earth. And joining us remotely is Charlie Duke, Apollo 16 moonwalker and Apollo 17 backup lunar module pilot. We also have with us from the Artemis generation, Jessi Horelica, and she's an Artemis flight controller. We have Antja Chambers, and she's an Artemis engineer. And we have Reid Wiseman, NASA astronaut. So we'll go into our panel discussion. So as we are celebrating the 50th anniversary of Apollo 17 on the heels of an incredible Artemis I mission, it's a real honor to be here with our legends and with our leaders. As we stand on the shoulders of you giants, we want to start by asking our Apollo legends a few questions. So I'm going to start with you, Gerry. You were the lead flight director on Apollo 17. Can you tell us what that entailed? What was it like preparing the mission control team for what became the longest mission of the Apollo program? What made 17 different?
Well, it wasn't much different than, let me answer that first, than 16. People have asked me sometimes, were we kind of starting to fade out and fall off? Not at all. We were as diligent on 17. We certainly didn't want to end with a failure of a mission after we had been there and done well. A lead flight director is an interesting position. It is primarily, and I discussed this morning with the head of the flight director office for Artemis, that it's the same. It's a pre-flight, a pre-mission responsibility. You're in charge of pulling all the pieces together. And you spend more time with the crew probably than the other flight directors, talking through mission rules, flight plans, emergency procedures, all of it. And you also got the network to worry about, your tracking systems and all that. Once the base of the rocket clears the tower, a flight director is a flight director. It's the guy sitting in that seat, or the gal now sitting in that seat, that has to make the final go, no-go decisions after a lot of help and a lot of input. So the lead flight director is a responsibility that's a big one, but it was primarily pre-flight. And it worked extremely well the whole time throughout that program. It worked very well.
So on Apollo 17, I know there was a lot of focus on the science on that mission, the distance that the rover traveled. Can you tell me about the preparations, the planning, getting ready for that?
Yes, one of the things that happened It actually started with the last 3 missions, 15, 16. 17 had a rover, and that made the exploration of the moon a lot better because they could traverse further. Now, of course, we always had them in walk-back distance was our key, so it was kind of a constant measure of how far we could go. But those last 3 missions were very similar, and they were, but they built on each other. And 17 was really the capstone of the program because it was the longest EVAs. The lunar module had been modified to give them a little more oxygen, a little more time on the surface. So we had the ability in 17 that we didn't have earlier. And it really did work. And by that time, I can see, and this, Gene and I have talked about this, we never took the focus off of crew safety. But in those latter missions, we finally got to the point we knew what we were doing and why we were going, and it was to explore the moon. So in the control center, I can tell you, particularly at the flight director position, there was a lot more emphasis on the science. And we went out in the field and trained with the crews, which we hadn't done prior to Apollo 15. And so we went out to remote sites here in the U.S. and watched how they worked with the science guys and how we could enhance that. So it was a learning experience, and you're going to go through the same experience with Artemis. Your first thing is get them up there, get them back, don't hurt anybody, and as you get more comfortable as time goes on, you'll get to pure exploration or better exploration.
Thank you. And so, Gene Kranz, as you shared, you were the Apollo 17 launch flight director, both Moon and Earth. On Apollo 17, it was the first night launch of the Apollo program, and you were on console. For our guests, why did we launch the crew at night, and did it create any additional challenges for the launch control at the Cape or mission control teams here in Houston?
Vanessa, before I begin, I'd like to say a few words to the Artemis team. I've been involved in every beginning of every mission from Mercury through, actually the space station program and into the shuttle. Our major concerns were always the unmanned missions, because a mission without a man available to exercise options that maybe we had not properly covered during our pre-mission planning was really key. When I looked at the Artemis profile, a 22-day unmanned mission, I almost wanted to know what they were going to do, what problems they would face. So I got together with a couple of the engineers from Lockheed, and I went over the alternate mission options they had in there, and I talked with Mike Haas and one of his engineers in there. And I got then into watching the videos program from a standpoint of the mission overview. And I just wanted to say, you did one hell of a job pulling that thing off, because it was incredible. Now the simple question is easy, why did we launch at night? Well, there's many things that go into establishing the launch window. But one of the principal ones is the sun elevation at the time of landing. And the sun elevation to provide the best visibility for the landing, through experience and verified in previous missions, is roughly between 7 and 20 degrees behind the crew at the time of landing. This improves their depth perception and allows them to basically exercise whatever actions they need to get to a proper landing site. And like I say, that was the easy question. I still go back to Artemis and want to say, you did a great job.
Thank you. So, Jessi, can you share your role on the Artemis I mission and talk to us about the parallels between the two programs and what it's like to be an Artemis flight controller in the past few weeks.
I had the absolute honor to support the Guidance, Navigation, and Control Console, the GNC console, and mission control for Artemis I. GNC and our 3 back rooms ensured Orion knew where it was throughout its entire journey, when and where to maneuver, and how to make it home safely. So it was just an incredible journey. We were also responsible for maneuvering and calculating those maneuvers to provide you the incredible imagery that you all saw throughout the mission, including that breathtaking Earth being eclipsed by the moon. It's truly something I know I will never forget. I think one of the parallels between Apollo and Artemis that sticks out to me the most is that both programs really embody the human spirit to explore and to dream big. And that is something that I have been inspired by throughout my entire career. And they also show that both programs can demonstrate the ability to have humans work together and achieve an incredible goal when you work together through a common goal. Let's see, the past few weeks have been an incredible ride. I got to live out a dream that actually started here at Space Center Houston as a little girl. So it's been an absolute honor, and I could not be more proud of the Artemis team and what we've accomplished. We can't wait to fly our crew on Artemis II.
For sure, for sure. Antja, as an Artemis engineer with expertise in water recovery systems, how does the work you're doing ensure the health and safety of our Artemis crews?
So currently, I'm serving as the Human Landing Systems Program. It's basically the portfolio manager of a lot of the hardware that's provided specifically for crew use. So anything from the emergency hardware to the food to the medical kits. All of it is meant to ensure the safety and health and ensure their performance during the mission. And so all of that ranges from making sure that they have the right medical supplies during their mission, that they have the right food that has the right caloric content for that. We also have what we call the lunar loo, which is the lunar lavatory on orbit. If you know one thing about NASA, we love our acronyms, and it's exactly what you say. It's about making sure that we have waste management on orbit, everything to protect the crew and make sure that they can do what we take for granted from a day-to-day basis, and to ensure that the safety is ensured during that.
Awesome, thank you, Antja. So joining us remote, yeah. I think the crews will tell you they appreciate knowing that we're working on that loo. So Charlie's remote, you're joining us remotely. Thank you for joining us. Can you hear me okay?
I see the stage and a few front rows, and you're loud and clear. So hopefully I'm visible to you.
Yeah, you're visible and loud and clear. On
Thanks.
Apollo 16, you were the lunar module pilot and one of very few people who not only walked on the moon, but rode the lunar rover on the surface. Then you became the backup lunar module pilot for Apollo 17. Talk to us about the crew of Apollo 17 and your memories of training with them after having returned on Apollo 16.
Well, of course, we were all close friends, the astronauts during Apollo. So when John and I returned, they needed a backup crew for 17. And we realized it was after that, there was no more crew assignments, but we volunteered anyway because who knows what might happen, and we might be a good support for the crew since we just got back, and we give them insight into the rover, stowage of the lunar module, procedures, and this kind of stuff. And so it worked out really well. We were a good support for them. We worked hard to learn the flight plan and to help in the planning. So being a backup crew on a dead-end job really was pretty exciting. We had good training down at the Cape, and so we got to know each other's idiosyncrasies and things like that. So we were able to help the prime crew and have inputs into some of the flight plan as far as the lunar surface activity goes. So it was we melded really well, and was delighted that I got to work on 2 backup crews, prime crew, and 2 times in mission control. So Apollo was very exciting for me.
So I happen to know you've shared with me before that you guys like to pull pranks on each other. Do you have any you remember of sharing pranks with Apollo 17?
Yeah, one that when Stu Russo was the backup command module pilot, and John Young came in one afternoon is panting as he'd been out running a rover track, which was out into the boonies, and he came across this big snake, and it was huge, he said, and so he said, I threw rocks at him, and I think I wounded him a little bit. So Stu Russo and I got our rental car, and we drove out there and found this big snake, and dispatched him, and said, well, let's have a joke, and so we took the snake and we coiled it up under Gene Cernan's chair in the crew office, and he was in the simulator, and we said he's got an important call. So secretary called him and said, you got an important call. So he took a break, and he sat down, and the chairs there were those roller chairs, and the desk had a little keyhole where you put your legs and you could roll it in. So he was rolling in towards that desk, and he looks down and sees this big snake, which was had been dispatched and beheaded, by the way. And he, Mach 2 backwards, and jumped out and said a few choice curse words, and was white as a sheet. And I said, John, I said, John, we made a big mistake here. And but everything, then he realized what had happened, and we got a few choice curse words and a few everything else, and everybody had a big laugh, and so we all settled down, and Gene took it really well in the end. So we had a few little things like that, but that was the most interesting one during our short training period with 17.
You guys actually had a really good time together.
Yeah, we did. We were, I think, being on the backup crew with that experience we had as with our 3 days on the moon, it was really helpful to them in their training, and we were able to give them some ideas about their traverses and what they should look for and everything else like that. And they did a fantastic job as we built on the expertise of the 3 previous missions with the rover. We got more and more confident with the rover, so I don't remember exactly how far Apollo 15 went, but we went out about 4 miles or so, maybe a little bit more. Well, 17 did 7 miles, and so with the confidence in the rover, we were able to expand the exploration territory, and it worked really, really well.
Awesome. Well, thank you for sharing that.
Pleasure.
So Gerry and Gene, this one is for both of you. What do you think Apollo did that will help Artemis the most? It's kind of a hard one.
I've thought a lot about that more in recent years than I did early on. I think the thing that we probably provided that will help them the most is the fact that we did it. When we started Apollo, it had never been done, and we thought we could do it, and we were a bunch of young people that had great leadership, and we pulled it off. And when I say we, I'm not just talking the Mission Control Center, I'm talking the whole system. We pulled it off. Now that takes that element out for Artemis. It can be done. We did it 50 years ago. Artemis will have much better tools to do it, technology tools, and I think it'd be very successful. But I think the thing that you can take off your plate and not worry about is that it can be done, because we did that. And I'm, boy, Godspeed. Yeah, have fun.
Awesome. Gene, your thoughts on that question?
Two major themes that existed during the Apollo program. There was a good relationship between the headquarters team, George Low, and basically throughout this entire process, it was a very personal working relationship. We didn't worry about level 1, level 2, level 3, and all that kind of stuff. It emerged actually from the prior programs, where basically we knew each other, were friendly with each other, and as a result, if we had problems, we could knew the right person to call to and talk about and bring issues to the front. I think the second thing was we had a gentleman by the name of Bill Tyndall. George Low had indicated the concerns about integration of all the aspects of the hardware, software, operations, procedures, all these things coming together. And he established what was called the mission techniques, or called the flight techniques. And these were raucous, sometimes 1 and 2 days meetings in there, where people would establish how we were going to do things. And finally, many of the people, a lot of times Tyndall's work would get in the way of my people in the trench, the control team, and the fight would come up on that topic. But Bill would sit down, and about 2 days after the meeting was over, he'd write a memo and saying, I was at this meeting, I listened well, right on down the line, and this is what I think you said. And then he would write a 2 or 3 page memo that would lay out the direction that we should take. And I think the key thing is, I think the Artemis program, extremely complex, has to find the Bill Tyndall equivalent to put these pieces together.
And it should be noted that Bill was here at JSC, but everybody in the agency trusted him to do it right. And boy, his Tyndallgram, we called them Tyndallgrams. You know, we were looking forward to getting the next one. And,
well, I think one also good thing is the minutes of the flight techniques meeting still exist. It's about that tall, about 3 inches. They were published by the people at Draper Labs. And as you move into this program, you might take a look about how this thing called Apollo came together, because there's a lot of good lessons there.
Awesome, thank you. Yep, you're bringing back fond memories of flight techniques meetings on shuttle. So, awesome. Well, so we do have some questions coming in from the audience, and there's a QR code. Thank you. Okay, great. All right, so one of our first questions is, and this is for anybody on, let's see, what challenges from 50 years ago do we still see today in getting to the moon? Up to all of our panelists.
The one thing I was taking away from all three of them, from Gene, Gerry, and Charlie, is we're still learning, and these three folks are still teaching us. And I think Gene, when you said it's the integration of all these parts, when I look across Artemis, it's vastly more diverse in its pieces now, with commercial industry involved, with international partners involved. The diversity of this team from bottom up is unbelievable, as well as the hardware. And so I think the thing from 50 years ago that is still going to be a major challenge, and our agency is talking about it every day, is how do we integrate all of these parts and who oversees that? So I thought that was a great comment. And I need to point out, because we have Charlie here, it's the 50th anniversary of Apollo 17. It's also the 50th anniversary of Apollo 16, which flew just a few months before 17. These guys flew to the moon, came back, and they're like, yeah, we'll be backup crew for the next crew. And I'm like, well, most people would be taking a month off and hanging out with their families. But what you all did in Apollo was just it was truly magnificent, and you motivated an entire world to get into science, technology, engineering, and math, and we all thank you for that.
Awesome.
Pick up on one thing. I think the one thing that the hill to climb yet for Artemis is the fact that the moon is still 240,000, give or take, miles away, and it's tough. It's a hard business. And somewhere along the way, you're probably going to get your nose bloodied, hopefully not too bad, learn from it, and move on. But I really do think I think it was Max Faget, it may have been Bob Gilruth, that said something after, and it was in the control center, because I heard it. He said, I think it was Faget, who was the chief designer at the time of almost everything manned spacecraft. He said, we made this look too easy. The next bunch needs to be aware of that. It's not easy. It's very, very hard. And but that's why we did it, and that's why Kennedy said that we're going to do it because it's hard. And just keep that in mind. It can bite you.
Indeed. And it was our pleasure this year to celebrate the 60th anniversary of the moon speech that John F. K. Gave, and which kicked all of this off. So yeah. What an inspiring time. So we're sitting here today at Space Center Houston, where future generations are inspired daily. When you're thinking about your unique position, whether it be on Apollo or Artemis, so this is for any of the panelists, what would you share with the young people today about what their future may look like?
I guess I'll take this one. I'll take part of it, I guess. It's what they make of it, right? Like, we're all building a foundation. Every previous generation is building the foundation for the next. And so it's to continue that with the baton. I think one thing that I don't think is taught as kind of early on as I would like to see is whenever someone says what the challenge is kind of going forward, they think that we can say, I don't say technical. For some reason, the technical challenges from an Artemis engineer standpoint is not really as intimidating as some of the soft skills in communication that is needed. And we hint on it here with integration, but soft skills. We all have different personalities, different opinions, a lot of smart people. Some voice their opinion very loudly, while some don't, but somehow we have to make sure we're all heard. And I think that in order to move forward and have that bright future, it's to understand each other in order to have that effective communication and ultimately integration. So, okay.
Okay, and the questions are pouring in, so I'm going to try to get through as many of them as I can. So for Mr. Griffin and Mr. Kranz, what technology used in Artemis do you wish you had in Apollo?
Can I take it? It's funny because in 1972, even when we flew 17, we had the best technology available, and we thought it was wonderful because it was all we had, and it was the peak at that point. Now, looking back, I would say if we had if we had had more computing power on board, we wouldn't have had to load and reload so many things through the display keyboard. It's called the DISCI. We would have had an ability to maybe just kind of run through it with one setup in the computer, and just like you do on your cell phone or PC or iPad, select what you wanted and just go on with it. But everything was slower. Then it had to be a little bit slower because we had so much to load. And we didn't have a good, the other thing, if you think about Apollo 13, with all the reading of checklists that we had to do, and Fred can tell you they ran out of paper to write on. We had no way to uplink anything like that. You had it in shuttle. You had a teleprinter that if you needed a new checklist, you just sent another one up. And we had to read all of that. So there were things like that that made it, and Jim Lovell just about came unglued on Apollo 13 because we were so late getting it up to him, getting the procedure to how to power up the command module after we had taken it all down. And I can tell you, they did it perfectly. But it sure would have been a lot easier just to zap that thing up there and have them run through it. That's the two things I think of.
So, Reid, I had a couple of ones for you. People want to hear from you in general, and then they want to know what you have learned from folks like Gerry and Gene. What about the Apollo missions that inspired you?
I always have to start by saying I wasn't alive, so that's a good step in the right direction. I think first and foremost, I have to look back to when I was selected as an astronaut in 2009, which for some of you seems like a long time ago. For me, it seems like yesterday. And the day we showed up, these folks were involved in our training. They were our mentors. They were teaching us everything that we needed to think about. And they've been there by our sides every day since. We just had a great talk with Jack Schmidt this past weekend at a reunion. And that's the biggest thing to me, is that they really embody the lifelong commitment to human exploration, and they have never let their guard down, and that is pretty awesome. And I was listening to Charlie earlier when he talked about how valuable it was to come back from Apollo 16 and work alongside with the Apollo 17 crew, and that is exactly what we should be doing in Artemis. When that 2 crew lands, 3 is going to be deep in training for lunar exploration, and I bet there's a lot they could learn about Orion from the crew who had just flown it, and so they should be working side by side, and then 3 should be doing the same to share that legacy with 4, and then maybe in 30 years down the road, I could be sitting with the new class that we just hired and telling them about lunar geology. I think it sounds perfect.
Awesome. Okay, so Charlie, I'm going to throw this out to you, Gerry and Gene. So how did working on such a big initiative change or develop you as individual people?
If I go back into the way we developed in mission control in the space program, we started off very early, I won't say ignorant, what I'd say hired hands. Basically, many times we'd arrive in mission control without knowing each other, and we had not developed what I'd say the relationships to truly become a team. As we continued to move through the program, however, every controller, every position was learning by doing. They were writing the procedures, developing the schematics, that type of stuff. And they would exchange this with the other controllers. And we developed the ability to work laterally and provide integrated solutions to the problems. Now this turned to be very important in Apollo and even the shuttle program, because between the mission rules and the learning by doing, developing the schematic, writing the procedures, we were able to help the program through the change board process and developing workarounds, identified problems, doing assessments for them. So I think it's very important early in this game for the teams that are going to be in mission control writing these procedures to basically provide a check and balance upon what the contractors are doing through the mission rules, self-study, basically to acquire the knowledge that is going to give you the confidence to speak out and say, hey, I think we need to do something different here.
I think all of us developed, as time went on, a confidence. And part of that was through the great, I mentioned it earlier, the great leadership that we had. They trusted us, our leaders, and pushed decisions down in those days, down to where the expertise was. And we would brief them, and they would, when we had a big issue like some of the stuff on 13, we would brief them and they would say, their major answer was, okay, how can we help you get it done? And we trusted the people below us. We had to, the flight directors, I'm talking below us. So to me, it became kind of a definition of what a real team was from top to bottom. And it's really an exposure to take on a difficult task like we were doing. And I hope you've got that same setup in Artemis. It takes the whole team. You know, we almost lost, in that era, the personal pronoun I. We used we all the time. We're doing it tonight, or this afternoon, or wherever we are. We seldom used the personal pronoun I, unless you were saying I think. But when we had a decision, it was we were going to do it, or we did it. And it didn't make any difference whether it was done by the astronauts or done by somebody in mission control. It was we. It was the team that did it. So I think that team concept just permeated through us.
Absolutely. And I will say that that is alive and well.
Good.
Alive and well. So Jessi, people want to know, what was your favorite moment personally with this Artemis mission?
There were so many of them, it's hard to choose just one. But I think it was the first time I was on console for an orbit shift, and we were maneuvering Orion to take its first public affairs imagery shot of the Earth. And I knew that there were commands on the vehicle that were from my team that were just about to execute. And it was incredible watching the time at which the commands were supposed to execute. There it goes, and Orion starts maneuvering to look at the Earth and show the first shot of Earth from Orion. So that was, I think, my favorite moment. There were, again, so many, it's hard to choose, but that was definitely a highlight of my first shift.
Yeah, and if you haven't seen the imagery from Orion, please go to nasa.gov. That's amazing imagery. Same thing. I remember one day I was in the control center and I just looked up, and it was when we were doing a close flyby of the moon, and I was like, oh my gosh, it's right there. We can just touch it. So let's see. Like I said, there's a lot of great questions coming in. Let's see. For Charlie, check your mic and see if you can respond.
I wasn't hearing you, but I was hearing everybody else. I hope you're hearing me.
Okay, so I can hear you now. People want to know, what did you like or not like about the lunar rover? Was there something about the rover itself?
The rover was a wonderful machine. For what it was designed for, I thought it behaved and performed admirably. We had a few little glitches. Apollo 15 had problem with the seat belt, so we redesigned the seat belts so that we could get in and out easier. And it would, with a four-wheel drive and double steering, we were amazed at the performance of the rover. We were climbing 20-degree slopes, and it was very stable. It was a little squirrely on the steering because it was so sensitive. And we tended to skid back and forth a lot. And we got so confident in the rover that our flight plan called us to navigate a maneuver at about 5 kilometers an hour, maybe a little bit faster. But coming off the hills in both 17 and 16, John was the driver, and he did a fantastic job. I was the navigator. And as he came down the mountain, we were all scale high on the speedometer. And so both 16 and 17 had that experience, and so we both claimed the moon speed record on our flights. Yeah, it was all scale high, so we were going at least 17 kilometers an hour. And it was bouncy. To me, one of the wisest things they did was to give the control of the TV to mission control. So all we had to do was turn it on and not worry about pointing this thing to keep track of us. So we were really busy. Everybody's busy up there. And getting in and out of the rover was not easy, but not really hard either. And so we had so much storage and everything like that. I didn't have any major trouble with the design of the rover. It was remarkably good for what it was designed to do, and that was carry 2 people around the moon and all the stuff that we had to carry. So Marshall and the contractors did a great job designing that, and we appreciated the effort they all put into it. It was fun.
Awesome. So like I said, there's lots of questions, but here's one from a high schooler. And the high schooler says, what can I do to take my passion of learning about space and turn it into a career? I'm going to shoot that to you, Reid. So from a high schooler, he wants to know, he or she wants to know what they can do to take my passion of learning about space and turn it into a career.
I'll start that one, but then I'm going to hand it off to our 2 other Artemis generation folks. This is an amazing time where you can take that passion anywhere you want. If I was in high school right now and I had found that passion, I'd be trying to get an internship at NASA. I'd be looking at where I want to go to college. I'd be working on some sort of a technical degree. And then from there, there's just so many opportunities. SpaceX, Boeing, Lockheed, Blue Origin, you name it, Virgin Galactic. There's just so many outlets right now that you can go apply yourself in. And then who knows, your life might take a little bit of a curve somewhere in there, and you may find a new passion along that road that takes you into some real specific technical job that you change the entire world. And that's a potential outcome of all of that. How about the NASA track? What should they do for the NASA track?
I think you covered a lot of it. So if I put my supervisor hat on and sitting on panels, we need a lot of talent that is looking at science, technology, engineering, and math-related career fields. And so like you had mentioned, one of our key ways that we hire into NASA directly is through the Pathways Internship Program. And so I strongly encourage that it's an opportunity for you to internship with NASA. You do several rotations from flight operations to the engineering directorate to human factors. There's so many opportunities for you to experience it and to see whether or not you like it. And if you do, then it would be a great path directly for hiring, but we also have a very talented contractor workforce as well, and they have internships. So we have Boeing, we have Lockheed Martin, we have KBR, we have Jacobs, and a lot more. So that's where I would encourage that you explore that, is to reach out to the Pathways and look up Pathways Intern. We also have several internship opportunities as well that we also bring in. So.
I will just add that you have a passion for a reason and follow it. That's what I did as a little girl sitting here. I was 7 years old and I saw the white flight control room on a tour from Space Center Houston, and that just sparked everything for me. So follow your passions, follow your dreams, and they can lead to somewhere amazing. I just flew a spaceship around the moon from that very flight control room that I saw as a little girl. So. Thank you.
Gene?
Generally, when I talk to the young people, I give them a few words: dream, aim high, and never surrender. And I think the key thing is, no matter what you're doing in life, schooling, running down the line, you're going to run into bottlenecks, you're going to run into times when you are just tempted to just quit right on down the line. And I think the key thing is to continue growing. Always set your goal high, and then once you reach that goal, move it a bit higher, and continue this process of growing and learning throughout your entire life. And that, I think, is the thing that was really key to our success in mission control. We never stopped accepting the challenge to continue growing and being better.
Yeah, I'm glad for that. So I'm being told we're going to have to wrap. And I know everyone, I still had lots more questions. And so just thank you all for the questions. But I want to thank our panelists. I want to thank our Artemis generation for being here and sharing your experiences over the past month and everything that's going forward. But I want to acknowledge and especially thank our Apollo generation, the panelists that are here. I see people from the Apollo generation in our audience as well. And I want to let you guys know that we truly appreciate everything that you did to set us on the course for now, returning to the moon and going forward. So just thank you, thank you, thank you. And Charlie, thank you for joining us remotely and sharing your wonderful stories with us.